In this video, you are going to learn about proportional relationships and how to solve problems that involve proportional relationships. But before we can do this problem on the screen, we need to know what we mean by the term. All right, so proportional relationships are relationships between two variables, x and y, where their ratios are equivalent. So two quantities are said to be proportional if their ratios are equivalent. As it relates to the two variables, the variables can be any letter of the alphabet. It don't necessarily has to be x and y. But what you need to know is which one is the dependent variable and which one is your independent variable. Which one depends on the other to change. So x is always the independent and y is always your dependent variable. All right. So in order for us to find the equivalent ratio, as we said before, we are going to divide y by x. We normally use this formula, k equals to y divided by x, where k represents what we call the constant of proportionality. Let me write it right here. This is constant. This is n right here, constant of. I'm just going to write PRO and some dots for proportionality. To find k, we divide y by x. So basically what you're doing here to find the equivalent ratios is taking your y values and divide them by x, all right? So if you look at the table here, they did not say which one of these quantities is your x or which one is your y. But x and y is the same as writing a coordinate, right? The x come before the y. So given the table, your first column is always your x and your second column is always your y. And this is only if the information or the data in the table is arranged in column forms. If it is arranged in rows, then your first row will be your x and your second row will be your y. So now that we established that, we are going to go ahead and divide. So 5 over 20 is the same thing as saying it's equivalent to 1/4. How did we get that? 5 into itself goes 1, 5 into 20 goes 4 times, so it's 1/4. 10 over 20, that's 20, 40. 10 over 40 is 1 over 4. 15 over 60, or 15 divided by 60, is equals to 1 over 4, because 15 into itself goes 1 and 15 into 60 goes 4. Now we are down to our last row here. 20 divided by 80 is equals to 1 over 4. Point to note, you have to take each pair and divide y by x. You cannot just do the first two and say, okay, the ratio here is 1/4. No, you have to make sure you do it for each one so that you can see whether or not the ratios are the same. All right. So once you do that, we are going to look at our ratios. Ratios is the same thing as fraction. So if you notice here, for every pair of y and x values we take and we divide y by x, we get 1 over 4. This is saying for every one push-up, because remember, y is in the numerator and x is in the denominator. So for every one push-up, there is how many jumping jacks? 4. All right. So all of these ratios are equivalent. Therefore, the two quantities in the table is proportional. So let us go back to the question. Are the two quantities proportional? We're going to write yes. And it says, explain your reasoning. Your reasoning should be because all the ratios are equivalent, or you can say all the ratios are the same. All right. These are the ratios right here. Also, if the question should ask you, what is the constant of proportionality? The constant of proportionality is 1/4 in this problem. Remember, the same way you find the equivalent ratios is the same way you find the constant of proportionality by dividing y by x. However, if at any point when you divide y by x here and we don't get the same ratio, right, or the same fraction, it is not proportional. For it to be proportional, it must be constant, meaning that you must get the same ratio every time you divide your y by your x. All right, just want to clarify that. We are going to look at another problem that involves proportional relationship. The question says, the total number of cookies is proportional to the cost as shown in the graph. Which of the following best describes the relationship? So if you look at the statements here to my right, all this is saying which one of these statements is true about the graph. In order for you to select your correct answer, first you must understand the graph are being able to interpret the information that is being represented on the graph. So the horizontal line at the bottom where we have the x is our x-axis, which represent the number of cookies, and our vertical line over here where we have our y is our y-axis, and this represent the cost in dollars. And this is our title here, cookies. So the graph is about cookies. So this straight line that passes through the origin is our graph, right? So we are going to find a point on the graph where the x and the y crosses each other. So I'm going to use this point right here. The point is just a location on the graph. So we are going to label our point, right? To label our point, we need what we call coordinates. Coordinates is basically the x and y value. What is x when y is this, or what is y when x is this? So if you look here, this point is when x is 4, y is going to be 3. So they crosses each other at this point. When x is 4, y is 3. So we label our point. So let's just find a different point on the graph. I'm going to use this one right here. So this one is saying when x is 8, y is 6. You can choose any point on the graph. I just choose to use those points in the corners because it is easy for me to identify my x and my y values. So what does these points mean as it relates to the graph? This is saying 4 cookies cost $3. 8 cookies cost $6. All right. So as it relates to this situation, right? Because remember, x represent the number of cookies and our x value in this point is 4, which is 4 cookies. Y represent the cost in dollars. And this 3 here is $3. So for 4 cookies, the cost is $3. Now, I'm looking at the statements here. It says 1 cookies cost 50 cents. So in order for us to make this conclusion that this, whether or not this statement is true, we need to take 1 point from the graph. I'm going to use when x is 4, y is 3. And I am going to label my point. This is my x, this is my y. And I am going to divide my cost, which is y, by my number of cookies, which is x. Because I need to find out the cost for 1 cookie. If I divide 3 by 4, I'm going to get 0.75, which is 75 cents. And I'm going to have 1 as my denominator. It's like you're saying 4 into itself goes 1, and 4 into this goes 0.75. So when I divide the cost by the number of cookies, it says for 1 cookie, it costs 75 cents. Therefore, this statement is not true about the graph. I could also take the other point and do the same thing, and I will end up with the same. For one cookie, it costs 75 cents. Now, let us move on to the second statement here. It says 4 cookies cost $3. So let us go back to our graph. When x is 4, as x represents the number of cookies, y is 3. Yes, that statement is true. As shown on the graph, for 4 cookies, the cost is $3. So this is our answer. And this is how you interpret the information on a graph and use the information to answer questions. All right. First, you need to know what the information is about. You need to know how to interpret the information so you can select which one of the statements is true, or so you can use it to answer the question. All right. Here we have another problem that involves proportional relationship. It says a garden hose fills 2-gallon bucket in 5 seconds. The number of gallons G is proportional to the number of seconds T that the water is running. Select all the equations that represents the relationship between G and T. So in order for us to answer this question, we must know what a proportional relationship equation looks like. It normally comes in the form y equals to kx, where k here represents the constant. I'm just going to write C for constant of, I'm going to write P for proportionality. So K represents the constant of proportionality. In order for you to write this equation, you must know what is K. To find K, we divide our y by our x. But if you notice in the problem, we were not given x and we were not given y. We were given G and T as our variables. As I mentioned earlier in the video, the variables are not limited to x and y. The question could use any variable, any letter in the alphabet. All right. But in order for you to know which one of these represents our x and which one represents our y, you must know which one is the dependent and which one is the independent variable. Apart from that, sometimes you're given some clues. For example, in this question where we have time, which is t, on the graph, time is always on your x-axis. So seeing that time is always on our x-axis, we are going to use t here for our x. And then if t represents x, which is time, then g is going to be our y, which is our dependent variable. So now that we clarify what is our x and what is our y, we are going to go ahead and find our k. So 2 gallons, so it's going to be, this is our y value, this is our x. As we said earlier, G, which represents gallon, is our y, and T, which represents second, is our x. So we are going to divide G by T, which is equals to 2 divided by 5. All right, you can either convert this to a decimal, or you can keep it as a fraction. So in writing my equation, I am going to have my k, which is 2/5, times t, where t represents x, and I'm going to have g right here on the left-hand side of the equal sign that represents my y. All right, so this would be the equation that represents the relationship between g and t. However, if the question says select all, so let us see which one of these equation matches the one that we have here. So this last one here matches this one. So at least we have one of the correct answers so far. So looking at this one here, we could not select this one because remember now that our constant is 2/5. All right. Also, we could not select this one either because our constant again is 2/5. If you look at this one, if we divide 2 by 5, we are going to get that as a decimal to be 0.4. All right, so our constant here is correct, but if you look at the variables, remember we said that t represents x. So remember the constant always multiply the x values. So this one is out. So this one here is our next solution. G equals to 0.4 t. So these are the two equations that represents the relationship between G and T. So we are going to look at another problem that involves proportional relationship. So it says a chef uses 24 pounds of flour to bake 8 cookies. The relationship between flour and cake is proportional. Let me just underline this. The relationship between flour and cake is proportional. How many pounds of flour does a chef need to bake 30 cakes? So we are going to use this information to write what we call ratios. So if you notice here, two things that we are comparing is flour to the number of cake baked, right? So I'm going to use number of cake. I'm going to write number of C, which represent number of cake. All right, so it says for 24 pounds of flour, you can write pounds of flour for here, pound of flour. How many cake did the chef bake? 8. So it's 24 to 8. Now, how many pounds of flour does the chef need to bake 30 cakes? All right, so when you're writing your ratio, make sure you put the same quantity under each other. For example, here I'm putting cake under cake and flour goes under flour. All right, so now it says how many pounds of flour? We don't know. We're going to call that F. Just going to use F to represent the variable since we're talking about flour, and F is the first letter of the word flour. Now that we have our ratio, we are going to write our ratio as fraction. Right, we're going to write a proportion. Remember that we said proportion is an equation in which two ratios are set equal to each other. So we're going to write them as fraction to write our proportion. So we are going to have 24 over 8 equals to F over 30. All we did was to turn them into fraction. Now that we have turned them into fraction to write our proportion. Now that we have our proportion here, just a point to note again, when you are writing your proportion, make sure you have the name of the same quantity in the numerator or the denominator. So if you look here, we have flour in our numerator, in both numerators, and we have number of cakes in both denominator. You cannot have flour over here in your numerator and then you have number of cake over here in your numerator. No, the name of the quantity must be the same in both numerator or both denominators, whichever one you want to use for your numerator or your denominator. So now that we have our proportion, we are going to go ahead and solve by cross multiplying or using the butterfly method. 8 times F is 8F, and 24 times 30 is 720. 20. Now we are going to solve our equation by dividing both sides by 8. The reason why we do that is because we want to isolate the variable f. To do that, we do the opposite of what the 8 is doing to the f, which is multiplication there. So we're going to do division to get rid of the 8. If you divide the left-hand side by 8, you do the same thing to the right. So on my left, I'm going to have f, and if I divide the right by 8, I'm going to have 90. So bear in mind that F represents the pounds of flour needed to bake the 30 cakes. So we find our F. So to bake 30 cakes, the chef needs 90 pounds of flour. All right. Once the problem sees that there's a proportional relationship, you can go ahead and use proportion to solve the problem. Proportion will only work if the quantities are proportional. If it's not proportional, then you cannot use proportion to solve the problem.